In our last lesson, we focused on interpreting the remainder, and we focused on two pieces of interpreting the remainder. We were either using the quotient or we were using the remainder to find our answer. This time we're going to be talking about quotient plus 1 and making a fraction and what those mean. Let's go ahead and take a look at our division and what each of these pieces mean. It's important for us to understand what each of our pieces in our division problem are and what they mean, so that when we go and divide, especially when we're looking at word problems, we understand how to identify these different parts. So our dividend, that's our whole, that's our total. That's what we're going to split into even groups. Division's all about even groups. Sometimes we have a remainder, we have something left over, but our groups are still even. The remainder is just off to the side. We can say if we have people in a house, the remainder is out in the yard. Then we have our divisor. That's the number of equal groups that we're separating our dividend into. Our quotient is the number that's inside each of those even groups. And then our remainder is what's left over that does not fit in those even groups. So those are what those four words mean, and that's important for us to understand. So again, our dividend, that's the total that we're separating out into even groups. Our divisor is the number of even groups. Our quotient is the number inside each of those even groups. And then the remainder is what's left over off to the side. Now there are four ways to interpret the remainder. Use the quotient, which we talked about last lesson. Use the remainder, we also talked about last lesson. Using the quotient is in a problem like how many full rides will they go on the roller coaster? Or how many whole slices of pizza will each child get? Use the remainder, we'd say, what's left over? After everything was separated out, how many cookies are left over? How many baseball cards are left over? So the remainder is the leftover pieces. Today we're going to talk about quotient plus 1. When are we going to use this? And then make a fraction. When are we going to make a fraction and what's that all about? So let's go ahead and take a look. We have quotient plus 1 and make a fraction. Now what I'm really going to focus on in this piece is the make a fraction piece, but let's take a look at quotient plus 1. If we're in a situation where we have quotient plus 1, that means we need to add 1 to our quotient. So in this case, our quotient is 4. Well, all we need to do is add 1 more to our quotient, so we should think our quotient plus 1 more would give us 5 as our quotient. And we'll talk about examples when this will be relevant. Now the really one that's tricky is the make a fraction. And we have a few steps that we need to write down when we're making a fraction. So make sure that you write these steps down so we don't forget, because they are a little bit complicated. Now we are going to take our quotient, and that's going to become our whole number. And that makes sense. This is how many each person's going to get if we're splitting something into even groups. So let's say we're talking about cookies. Each person, we have 23 cookies and we're splitting those among 5 people. Each person would get 4 whole cookies, but we want to use all of the cookies. We don't want to leave any cookies off to the side. Everybody loves cookies. So we need to figure out how do we use those extra remainder pieces. We don't want them to go to waste. So we're going to make a fraction. We can have a fraction of a cookie. You can have a half of a cookie or a fourth of a cookie or a third of a cookie. So we need to use those leftover pieces. We don't want any of those cookies to go to waste. So what we're going to do is the 4, the quotient, represents the whole number. That's how many whole cookies everybody's going to get. Our remainder of the 3 right here is going to become a numerator to a fraction. That's the number on the top of our fraction. That's how many little sections of cookie each person's going to get. And then we want to know, well, how many total little sections is each cookie going to be separated into? That would be our divisor right here. That's going to be the denominator of our fraction. So if we were using our cookie situation, each person would get 4 whole cookies and 3/5 of a cookie. So if I had my cookie, I could split this up into 5 pieces. So each person would get 4 whole cookies, pretend like these were all the same size, and then they would get 3/5 of the cookies that are left over. So that's a pretty good deal. I'd much rather have 4 and 3/5 cookies than just 4 cookies if it was me. So we don't want, when we're in situations where we don't want anything left over, we are going to make a fraction. So again, I'm going to write out our steps for this because it's important for us to know all of the steps that we need to take when we're making a fraction. So our first step is our quotient becomes our whole number. The answer to our division problem is our whole number. Our second step is our remainder becomes our numerator. That's how many little pieces each person's going to get from those pieces that are being separated. And then finally, step number 3, our divisor becomes our denominator. So that's how many pieces each of those wholes that are left over are going to be separated into. All right, now that we know how to make a fraction, and we understand quotient plus 1 a little bit, let's go ahead and talk about some word problems where we would use these two different ways to interpret the remainder. Our first word problem says, Emily's soccer team has 22 players. Or Emily's soccer team of 22 players. We're going to a tournament. 4 players can fit in each car. How many cars are needed so that all players are transported to the tournament? Let's think about what this question's asking us. We have a total of 22 people that are going somewhere. They need to be transported from one place to another. But only 4 people can fit in a car at once. We need to know how many cars we're going to need. Now, if we think about our division problem, 22 divided by 4, we can realize pretty quickly that 4 does not go into 22 evenly. So we're going to have a problem. Emily doesn't want to leave her friends sitting on the sidewalk while everybody else is at the soccer tournament. So we need to do something about that so that all the players can get from one place to another. How would we make that happen? How can we make sure all the players get from one place to another? We could draw a picture to help us if that is a way that would make it easier for you to visualize this. So we have cars, and only 4 people can fit in a car at once. So I draw a car and have 4 people inside that car. So there's 4, 8, 12, 16, 20. So I'm at 20 right now, and I have 1, 2, 3, 4, 5 full cars. But what's going to happen to those 2 people that are left over? We can't just leave them sitting on the sidewalk while everybody else enjoys the tournament. We're going to have to add another car so that those people can go. It doesn't matter if there are only 2 people in that car. We want those people to be able to go on to the soccer tournament as well. So we would add another vehicle. Yes, this is no longer an equal group, but that's okay. Our division would still show our equal groups. We would have 5 full vans, and we'd have a remainder of 2. But in order to transport all of the players, we're going to need to add 1 to our quotient. So this is a quotient plus 1 problem. And we see with the pictures that we drew that in order for everybody to be able to go to the soccer tournament, we're going to need a total of 6 cars. Now, we got 6 by drawing a picture, but we could have also looked at our answer. And if we identified that this was a quotient plus 1 problem, because we don't want people sitting off on the side, we could take our 5, that's our quotient, and add 1 more. That's how we got our answer of 6 cars are needed to transport everybody to the tournament. That's a quotient plus 1 problem, when we need to make sure that everybody can get somewhere, or everything can get transported from one place to another, or all of the items can go. We need to add 1 to the quotient to make sure that nothing is left out. Let's take a look at another problem. Jonathan is sharing pizza evenly with 3 of his friends. The pizza is cut into 10 slices. How many slices will each person eat if they eat all of the pizza? So we don't want anything left over. We can draw a picture to help us with this problem. We also need to think about, well, how many people are sharing this pizza? We have Jonathan, and he's sharing it with 3 of his friends. So Jonathan and 3 friends, this is 1 and 3 more, so that makes 4 people are sharing our pizza. And our pizza is cut into 10 slices. So if we drew a picture of our pizza, and we cut it into 10 slices, how many pieces could each person get? We're going to give them all a letter. So we would have person A, B, C, D. They'd all get 1 slice. Then we have more, so we can do A, B, C, D again. Everybody would get 2 slices. But then it says they need to eat all of the pizza. They eat it all. And they eat it all evenly. Well, I notice that I have 2 extra slices left over. How could I make sure that all the pizza gets eaten and it's eaten evenly? What could I do with those 2 slices if I'm sharing it with 4 people? I could just split those slices in half. A, B, C, D. So now how much pizza would each person get? Person A gets 1, 2, and a half slices. Person B gets 2.5 slices, C gets 2.5 slices, and D gets 2.5 slices. So my picture shows me how many each person gets. But let me think about that in terms of division. I can set up my division problem as 10 divided by 4 because they're sharing it with 4 people. When I divide, 4 goes into 10 2 times. 4 times 2 gives me 8, which leaves me with the remainder of 2 more. This is a make a fraction problem. It's a make a fraction problem because I can take a pizza slice and split it in half. There's nothing that tells me that I can't do that. When I'm talking about food or when I'm talking about measurement, I can split those into pieces pretty easily. Now you should have some notes that help you with your make a fraction. We also have our picture that can help us. So what we're going to do is we're going to take our quotient. That's the total number of pieces that each person's going to get. I separated my pizza out into 4 even groups. So each person's going to get 2 slices of pizza. And then what's going to be left over? Well, they're each going to get 2, and my divisor is 4. So they're going to get 2 2/4 slice pizza. Now you might say, but Miss Ike, I'm looking at the picture and they got a half. Let's take a look at this fraction. We haven't talked about fractions yet, but we can look at 2/4. Let me draw a picture to help me understand this. So I'm going to draw a rectangle. This is like my slice of pizza. And I'm going to cut it in half. And I'm going to shade half of this rectangle in. This half is equivalent or equal to 1/2. Now, I'm going to split my rectangle in half again. How many parts are shaded out of my total number of parts? 2 of them. And I have a total of 4 parts now. Did I change, though, how much was shaded? No, all I did was split my rectangle into pieces. So 1/2 and 2/4 are equivalent fractions. So when I set it up as my fraction, if I'm making a fraction, 2/4 would work. I could also write, if I drew a picture like I did here, 2.5 slices. They both mean the same exact thing. So my answer, how many slices will each person eat if they eat all of the pizza? Well, they eat 2 2/4 slices of pizza, or 2.5 slices of pizza. All right, I want you to take a look at some of these problems. The first thing that I need you to do, really think about what the problem is asking you. Draw a picture if you need to. I want you to identify, is this a make a fraction problem, or is this a quotient plus 1 problem? What is our problem aiming for? What do we need to do? Then I want you to solve that problem. Our problem says Carson was building a bench. She had 8 feet of wood that needed to be cut evenly into 3 pieces. Using all of the wood, how long will each piece be? Think about that for a minute. You could draw a picture to help you. She's cutting 8-foot-long piece of wood into 3 even pieces. What would my division problem be? Well, my division problem for this problem would be 8 divided by 3. I could do that right to start with, but I really want to understand, what is my problem asking me? So I'm going to draw a piece of wood. Here's my long piece of wood, and this is 8 feet. And it says she's splitting it evenly into 3 pieces. How long are each of those pieces? We have to use all of the wood. Nothing can be left over. Now, just like with our pizza problem, if we didn't want anything left over, we had to make a fraction. When we're looking at feet, we can always make a fraction with units of measure. There are a half of a foot, a fourth a foot, and we can identify those values pretty easily using a ruler or a measuring tape. So we're going to be making a fraction for this problem. I want you to divide and then make a fraction. What is this problem going to look like? What's our answer going to look like? How long is each piece of wood that Carson's going to cut? Well, if we divide 8 divided by 3, 3 goes into 8 2 times, and then we have a remainder. 3 times 2 gives me 6. 6 plus 2 more give me 8. Oh goodness, we're at 2 remainder 2 again for this problem. Now we need to make a fraction. So we're going to take our quotient, and that's going to become our whole number. Our remainder is going to become our numerator to our fraction. And then our denominator is our divisor. We need to know which of these numbers is our divisor. That's how many pieces we're splitting our piece of wood into. It wouldn't make sense if we had a denominator of 8. That's not how many pieces we're splitting our wood into. That's the total number of, or the total length of our wood to start with. So we need to be using the divisor. That's how many pieces we're splitting it into. So this is a make the fraction problem. And our answer would be 2 2/3 feet. That's how much wood she's going to cut. Or that's how long each piece is going to be, so that she uses all of the wood. We don't want anything left over. We don't want any scraps left over. If she only cut each piece of wood into 2 feet, we'd have an extra 2 feet left over, and we don't want anything left over. We don't want things to go to waste. Our next problem. Kylie is wrapping presents for her friend's birthday. She had 17 inches of ribbon that needed to be cut into 4 equal pieces. She wanted to use all of the ribbon. How long will each piece of ribbon be? Think about it. What are we doing with this problem? Is there a picture that you can draw to help you? For this problem, we're going to be dividing. All of these problems we're dividing, but we need to know why. We have a total, and we're splitting it or cutting it into 4 equal pieces. Those equal pieces, that's telling us, okay, we're going to be doing some division. We also know that she needs to use all of the ribbon. We don't want her to use just some of it. We don't want anything left over. She needs to use it all. We need to know how long will each piece be. So you could draw a picture to help you. Take that 17 inches of ribbon and separate it into 4 pieces. We can also divide 17 divided by 4. What type of problem is this going to be when we're all done with it? If we don't want anything left over, we don't want a remainder, what type of problem is this? This is a make a fraction problem. Now that we know it's a make a fraction problem, we need to divide. So we need to think 4 goes into 17 how many times? If I was splitting 4 evenly, or 17 evenly into 4 groups, how many times would it split evenly? It would split evenly 4 times. 4 times 4 gives me 16. That means I have 1 left over. So I have 4 remainder 1. Now I need to take this information and put it into a fraction. So my 4, that's how many whole inches each piece is going to be. That's going to be my whole number. My 1 of my remainder, for my leftover foot, 1 of those little pieces is going to go extra for each ribbon. And then how many little pieces am I separating it into? My divisor tells me that, which is 4. So she is going to need to cut 4 1/4 inches of ribbon so that she uses all of her 17 inches of ribbon. Last problem we're going to take a look at today. Jacob was in line for a roller coaster with 18 of his friends. Only 5 kids can ride at one time. How many rides are needed so that everyone gets to ride the roller coaster once? We don't want anybody to be left behind. Everybody needs to ride. Is there a picture that you can draw to help you with this? Only 5 kids can ride at once. What are we going to do? Well, we need to think about this problem carefully because we have Jacob and he's with 18 of his friends. So we need to consider all of them. So we have a total of 19 kids that need to go on the roller coaster. If you put 18, think about all of those people. We don't want people left behind. So we have 19 people that need to be going on the roller coaster, but only 5 people can go at once. If we drew a picture to help us, we would say, okay, well, there's 5 people on one ride, 5 people on the next ride, 5, 10, 15, 20. I don't have 20 people. I only have 19 people. So 5, 10, 15, but then what would happen to those 4 other people? We don't want to leave them behind. They need to ride the roller coaster too. In order for them to be able to ride the roller coaster, we need to add another ride. So even though this only has 4 people in it, we need to make sure that those 4 people get to go on the roller coaster too. If we were solving this problem, we would have 3, remainder 4, as our answer. But that doesn't answer our question. We want to know how many rides are needed so that everyone gets to go on the roller coaster. This is going to be a quotient plus 1 problem. We want everybody to ride on the roller coaster. Our picture showed us that we're going to need 4 total rides for everybody to ride on the roller coaster. That's how a picture can really help us. We can also look at our quotient and know that we need to add 1 more so that these 4 kids get a chance to go on the roller coaster. So our question says how many rides are needed so that everyone gets to ride on the roller coaster. We're going to need 4 rides. That's our lesson for today. Takeaways are, make sure you understand why we are doing the things that we're doing. Read those questions carefully. Make a picture in your head. Remember, our dividend, that's the total number that we're splitting up. Our divisor is how many groups we're splitting it up into. Our quotient is how many goes in each of those groups. And then our remainder is what's left over. We can make a fraction if we're doing things like measurement or if we're doing things with food and we need to use everything. We're adding 1 to the quotient when we don't want people left behind or we don't want items left behind. We need everything to get from one place to another. There is everything we need to know about interpret the remainder. See you tomorrow.